So the first thing I want to talk about is why LLMs, why look at large language models. We often hear a lot of questions about LLMs. Is the hype around them real? Is this an iPhone moment for the industry, or is it sort of a hype moment where everyone gets excited about a technology that ultimately doesn't work that well? Are LLMs a threat or an opportunity in different areas of business, in different areas of software development? How do you use LLMs to gain a strong competitive advantage in whatever industry you're in? And finally, how do you quickly apply LLMs to your own data? So we're going to talk about all of these really quickly, starting with the first one. And, we believe, a lot of people believe that LLMs are quite a bit more than hype. They are revolutionizing every industry that involves some form of human-computer interaction and some kind of like language data or interfaces, or in general, working with language. Here are some examples of just like recent stories about the impact of LLMs. So Chegg is one company that saw its shares drop significantly because it found out that users were using ChatGPT to answer questions instead of using its service. So it's had an impact there, and they have to think about how to adapt their business in sort of this age of LLMs. Many companies are building brand new products using LLMs. For example, U.com is a startup that does search, but really is focused on a search assistant that can look at personalized results for you, look at the content of those pages, and give you high quality, complex results and cited sources. It's only really possible using LLMs. And even existing machine learning tools like GitHub Copilot are becoming much more powerful with the latest generation of LLMs. GitHub Copilot is this code assistant that helps you autocomplete code essentially, but now it can also do things like fix your code by looking at errors, generate tests, and so on. All new functionalities thanks to more powerful language models. At the same time, LLMs are not that new as a fundamental technology. They've existed for years, even in the current form with deep learning, with models such as BERT that were out there. So why should you care about them now? And really, the story here is that the quality of these models has gotten significantly better as we've gained experience with them. So at the beginning, people would train language models, and we'll talk about this in detail. You could train a model on a bunch of text, and then you have to customize it a bunch to get it to do a specific use case. Like, for example, looking at product reviews and figuring out whether they're positive or negative, or figuring out, what aspect of the product they're about. So even though you had this underlying technology, you had to do a lot of hand coding, data collection, machine learning to actually turn it into a useful application. And as we've gotten better at building and tuning LLMs, we've managed to make LLMs that you can just give instructions to in natural language that can now do a lot of useful tasks with very little human effort to set them up. So it's really kind of a combination of two things that are enabling all these powerful applications, even though the machine learning part of this has been the same for a while. The first is that accuracy and effectiveness have hit this tipping point where, first of all, many use cases are now possible thanks to the accuracy, but also importantly, it's accessible to everyone thanks to the ability to instruct them in natural language. And also, increasingly, there's been more and more high-quality data and tooling available. A few years ago, if you wanted to build something using LLMs, you had to crawl the web and collect clean data sets and do all kinds of stuff from scratch. Today, you can find a lot of great, open data sets that have been collected. You can find entire open source models that are very high quality in, particular use cases. And of course, sometimes you do want to do a lot of computation, but you can get a lot of great commercial services like GPUs from your cloud provider to make that happen. So what is an LLM specifically? Well, it's a large language model. Large, of course, is in the eye of the beholder, but it's one of these things where it's increasingly called large simply because it's larger than the ones that people tried to use before. And essentially, one of the main ways that it's large is that it's also trained on very large amounts of data. So what exactly is a language model, though? That's maybe the more important question. A language model is a statistical model that tries to predict words in text, in some kind of language. So the way to set this up, it's basically a statistical problem. You have a collection of text, and you say, hey, if I show you some words, like say the beginning of a sentence but not the end, can you predict what the missing words are? And this is sort of a prediction problem. This is the kind of thing that we've been doing in machine learning and statistics for a long time. There are lots of ways to try to fit a model to the data to predict these words. But it turns out that, in the past few years, we've developed ways of doing it that can get better and better accuracy, especially as you feed in more data. And this ability ultimately gives you models that learn useful things about the world or can be used to sort of query interesting information about the world. So just to give you a sense of the scale that these operate on, a typical person might read a few hundred books in their lifetime, like say 700 books on average. That's a lot of books. It takes a long time, but it's not much compared to what we feed into a large language model today. A large language model, one book is about 80,000 words, which when encoded into the form that a language model takes is 110,000 tokens. A token is sort of a piece of a word. We'll talk a lot about them later. So, but your typical model, like say ChatGPT, is often trained on trillions of tokens today, which means tens of millions of books if you do the math. So that's a lot more books than a person would ever look like. And if you have a way of turning these into a useful statistical model, you often end up with something that can be applied to real-world tests. So just as a very simple example of how you can use this language modeling ability to capture knowledge about the world, imagine that I wrote the sentence avocados are, and then I left a blank space, and I asked the model, can you predict which word is more likely in there? If I have a good statistical model of language, I can use it to learn some things about avocados. For example, if I wasn't sure what color avocados are, I can try putting in a bunch of different colors and asking, how likely is it that it's that answer? And the model will say it's much more likely that the word after blank is green, avocados are green, versus avocados are blue. So in some sense, the model learned something about the color of avocados, even though it doesn't, really know what an avocado is. It just knows about the probabilities of words. Likewise, you can figure out, avocados are delicious, avocados are probably not intelligent, all kinds of things like that. And if you take this ability to the extreme, use it in more complicated ways, you can get these models that will do things like generate text with specific properties, like generate a song about sunset in Santa Monica, or classify data. You can ask it, is this a good or bad review? And it will do that. And these are all based on sort of the knowledge about the world and about reasoning that it gleaned from seeing a large amount of text. So what does that mean for you as a developer and user? Well, LLMs can automate many tasks that previously required a person to do them in detail, that usually involve imprecise language or knowledge about the world that's like kind of hard to codify and put into a computer. And these can help both accelerate innovation and build new features, new interfaces to software, and just increase ROI and efficiency of a business. So just some of the examples of things you can do with it. You can speed up software development because, a lot of software is is code. It's in a language, and you can get these assistants that are good at specific parts of it. You can democratize AI itself. Many users can now use LLMs by just talking to them and asking them to do things instead of doing a heavy-duty machine learning project. You can open up these rich use cases like assistants, analyzing documents for business, all kinds of things like that, generating ad copy and stuff like that. And of course, you can reduce development costs of applications, and you can reduce monotonous tasks that people have to do, get the easy stuff to a model, and get people to focus on the hard stuff. So we're just beginning to scratch, the use cases. You'll see a bunch more throughout the course. Now, unfortunately, with LLMs, there's no perfect or magic bullet model. So once you get past the idea of like, what could I use this for, and try to actually use it in an application, the right model will depend a lot on the requirements for your application, and there'll be a lot of trade-offs required and potentially quite a bit of custom development. So here are some of the factors you want to take into account when thinking about an application using LLMs. The first one is the model's quality. What kind of quality can I get from it? Can I find a model that I can use out there that's high quality, or do I have a way to improve it myself? Or do I need to sort of wrap the LLM around in a bigger application that uses this unreliable component to do something reliable at the end? So that's an important piece. The second one is the serving cost. This depends a lot on what you're trying to do. For example, and this is the cost of just running the model and getting a prediction. For example, if your application is like reading a couple of documents per day and extracting some information from them, it's okay if it costs, $1, $10, whatever for the LLM to process one document. It's totally fine. If your application is placing, ads on a web page that are customized to each user, or as they click through the site for your store, selecting recommendations for them, you can't afford to spend, many dollars each time someone looks at a page. You need to serve, millions, maybe hundreds of millions of instances of this per day at a moderate cost. So you'll really optimize for cost. Serving latency is another important factor. Again, if you're doing some offline analysis, it's okay if it takes minutes for your application to run. But if you're doing something in an interactive web page, it better run in a few milliseconds to get high quality application. And then the final one that can be tricky and is important to think about is customizability. If you have an important application, you're going to want to keep improving its quality over time, debugging it when something goes wrong, and generally sort of making it better and customizing it. So you need to think about, in different solutions, what knobs do I have to control, how well this is doing, to monitor it, to make it better, to prevent certain kinds of bad behavior that I don't want it to have, and so on. So this is an important thing to think about as you design your LLM application. So who is this course for? In this course, we wanted to really make it useful for practitioners and bridge the gap between two things that you can find out there today in other courses. So one of them is just black box solutions, like a third-party, LLM as a service API that you can call, where the tutorial is really easy. It just says, okay, just put in your text here and call this function, and you'll get a result back. But it's really hard to then take this and customize it, put it into a bigger application, and make sure you can get the best quality, the best performance, and so on, because it's basically one model for everyone. So that's on the one hand. And then on the other hand, there's the first principles of how LLMs work, how machine learning works, how to think about building a pipeline that's reliable, that you often find in academic courses, on theory and algorithms and so on. So we wanted to build this practical course that's in between, so that when your boss asks you, can you do something with LLMs in my application, and you really care about making it work well and getting it right and so on, you have the tools to build your own application using existing components out there and refine it and make it really great over time. And we hope this gives you a sense of both some of the research and academic foundations of this space, but also some of the engineering things you can do to reliably create high quality application to the best of our knowledge of what we know how to do today. So that's a little overview of the course. We hope you enjoy it. We had a lot of fun putting it together, and we're very excited to see what you build with LLMs.